Good afternoon, class. As usual, let's start by me answering any questions you might have. Okay, any questions with regard to the subject matter so far? Anything you want to clear up? There's a question, magmo-move ba uli yung deadline ng quiz since down ulit yung UVLE? Yes, that's halos sigurado na yun, ano. Obviously, you cannot do the quiz if UVLE is down. It's just that hindi pa namin alam kung kailan gagawin yung deadline, no? Pinag-uusapan pa namin. But definitely magmo-move yan. Obviously, yung deadline would be dependent on when UVLE comes back online. Yung problem set deadline will not be moved. Wala namang kinalaman yung problem set sa UVLE. Unless you're relying unless hindi pa nyo dina-download yung material that was provided in UVLE. But the problem set has very little to do with UVLE. There's going to be a problem set that will be released for week 2. Yes, that's right. You can use another question. I'm just reading from the chat. Better if don't direct your message to me, sa chat para makita nun lahat ng tao. You direct your message to everyone. No? So there's a question, may we use multiple colors in our solutions for the problem set? Yes, you can use multiple colors. Yung iniiwasan lang namin is it's something that's printed, because if it's printed, it's very easy to, of course, redistribute. No? So yun lang iniiwasan namin. We want it to be handwritten. But if you want to use multiple colors, you can. May I know from the people here, you can answer to the chat, how many have already started the problem set? You can be honest. Dalawa lang? Okay, so marami-rami na rin. So how do you find it so far? Madali lang, di ba? Quite easy? Or I think the problem, well, I wouldn't say it's trivial, no, but I think as long as you understand the principles that we discussed last week, I think the problem set is very straightforward. Nothing tricky about it, no. Walang ano, walang mga walang basta straightforward lang yung mga solutions and should be able to solve it in quite a short time, no? Mahaba yung ibang equations. I don't think the equations there are long, ano? If the equations are ending up being too long, you might be making a mistake somewhere. Okay, since wala na kayong mga tanong, sayang naman yung oras, no? I think we better if we start the lecture already. Okay, so this is part 2 of circuit analysis techniques, no? Just to recap, ano yung kinuha natin last meeting? Okay, well, last week you learned Kirchhoff's current law and you learned Kirchhoff's voltage law, which are the two fundamental laws that are used in circuit analysis. Then last meeting we studied ways of simplifying circuit analysis. One way of simplifying circuit analysis when we're not interested in too many variables in a circuit is we use circuit simplification. Yung circuit simplification na pinag-aralan natin so far, this is limited to resistive networks. Okay. Resistive networks. So we took up circuits in series and circuits in parallel. No? By the way, in relation to circuits in series and circuits in parallel, no? I want to warn you that sometimes you cannot find elements that are either in series or in parallel. No? Let me give you an example. Okay. Okay. If you take a look at this circuit, with respect to A and B, you cannot find any two resistors that are in series, and you cannot find any two resistors that are in parallel. So no resistors in series. And then there are no resistors in parallel. Okay, so I just want to warn you that it is not possible with the techniques you've learned, it's not possible all the time to simplify a resistive network because as in this example, there are no resistors that are in series and there are no resistors that are in parallel. No? Nakikita ba niyo 'yon? Walang naka-series, walang naka-parallel. Remember, two elements are in series if at their point of interconnection nothing else is connected. I cannot say that this is in series with this kasi dito may iba pang nakakonect, no? And then two elements are in parallel if they are connected at both their ends. I cannot say that this is in parallel with this because this end is not connected to this end. No? There is a resistor in between. Now, in your future courses or maybe later on in the course, you're going to find a way of getting an equivalent circuit for this, no? Pero for this part of the course, hindi pa natin ini-introduce yung paano ano, no? Paano magkaroon ng equivalent circuit nito, no? Okay, so anyway, going back, no? So we learned to simplify resistive circuits when there are elements in series and when there are elements in parallel. And we also learned how to simplify sources in series and sources in parallel. And then when we discussed sources in series and sources in parallel, we saw that sometimes you might end up with an invalid circuit. So be careful of invalid circuits. And then the other thing we learned was voltage division and current division. So ano yung, just to review, ano yung voltage divider? This is just to review. Okay. If I have resistors in series, and then the voltage across the entire series is V, let's say this is R1, R2, all the way to Rn, VRI is equal to V multiplied by Ri over summation of R. Okay. So, meron kang VR1, meron kang VR1, VR2, VR2, all the way to VRn. VRI is equal to V multiplied by Ri over the summation of R. And simply stated, we're saying that the voltage will distribute to the different resistors proportional to the value of the resistance. So this is the mathematical expression for that statement. It distributes proportional to the value of resistance. Then we also studied resistors in parallel. Where this is R1, R2, Rn. If this is the total current I that is flowing, okay, you have I1, I2, all the way to In. Okay. The current I's of I is equal to I multiplied by G's of I over the summation of G. Okay. I's of I is equal to I multiplied by G's of I over the summation of G. Or if you want to write that, in terms of resistances, I's of I is equal to I multiplied by 1 over R's of I over summation of 1 over R. So that's the other way of writing that expression. Anong sinasabi dito? The current distributes, okay, so this current I distributes to the different resistors proportional to the value of conductance. Okay, so that's what this is saying. Okay. So if you have two resistors in parallel and they have the same conductance values, then the current will just split in half. One half will go to one resistor, one half will go to the other resistor. Okay, so let's move on. So this is what I'm going to cover in this lecture. First, we're going to take up some terminologies that are used to describe circuits. So itong mga common terms na to. So I've been using a lot of these terms already, and I guess you've been sort of understanding these terms by context, but now we'll formally define some of these terms. And then we're going to discuss, okay, how do you do circuit analysis using a combination of KCL and KVL? And then if there's time, I'm going to introduce you to nodal analysis. There's not that much material in this particular lecture, so hopefully we won't be hurrying up. Okay, so just to introduce you to some terms used to describe circuits. First, node. So I already defined that last week and even last lecture. This is the point where two or more elements connect, node. Okay, this is a new term, essential node. This is a node where 3 or more elements connect. A point where 3 or more elements connect. No? In other words, none of the elements connected in an essential node are in series. If you have an essential node, that means none of the elements connected to that essential node are in series. They will only be in series if there are only 2 elements connected to the node. No? But once there are 3 or more, none of the elements will be in series. Okay, a path is a trace of adjoining elements with no element included more than once. A branch is a path that connects 2 nodes. Okay. Later on, I'm going to give some examples. A branch is a path that connects 2 nodes. Kung meron tayong tinatawag na essential node, meron din tayong tinatawag na essential branch. No, an essential branch is a path that connects 2 essential nodes without passing through an essential node. Path that connects 2 essential nodes without passing through an essential node. A loop is a path whose last node is the same as the starting node. A path whose last node is the same as the starting node. And finally, a mesh is a loop that does not enclose any other loop. Okay. So these are the terms that we often use to describe circuits that I guess you've been you've been hearing these terms and you know the meaning by context, no? But ito yung mga formal definitions nitong mga terms na to. Let's take an example. Okay. Identify all the nodes in this particular circuit. Actually, medyo naka-label na, no? Okay? Naka-label na. All of the nodes. Okay. So the nodes are A, B, C, D, E, F, and G. Okay. A, B, C, D, E, F, and G. Okay, ano yung definition ng node? Point where 2 or more elements connect. No? So A, B, C, D, E, F, and G. So may tanong ako. Ito, hindi ba ito node? Itong point na to? Isn't that a node? May I hear some answers? Okay. This is not a separate node, no? Because this point and this point are actually the same. In other words, ang node natin is actually this. The blue, this is actually the node, no? This whole thing. Ganun din dito, no? Sa baba. When you think about the node, this is the node, no? Okay. Now, dito sa ilang nodes to? 1, 2, 3, 4, 5, 6, 7, no? We have 7 nodes. Dito sa 7 nodes, which nodes are essential nodes? Which nodes are essential nodes? Okay. O ganito na lang. Which nodes are not essential nodes? Okay? So may mga sumasagot na, no? But para mas konti yung mga sagot, which nodes are not essential nodes? Okay, I have an answer. A. Okay, that's right, no? The nodes that are not essential nodes are A, D, and F. Okay? It is not an essential node if there are only 2 elements connected to it. No? It's an essential node if there are 3 or more elements that are connected to it. Okay. So A, F, and D, those are the non-essential nodes. No? So the essential nodes are just B, C, E, and G. B, C, E, and G. There are only 4 essential nodes. Okay, identify all of the branches. Okay, identify all of the branches. Anong definition ng branch? A branch is an element, is a path that connects two nodes. No? A branch is a path that connects two nodes. Balik nga natin. Path, ito, no? A branch is a path that connects two nodes. So what are my branches? My branches are simply my elements. Ano? This is a branch. It connects A and C. Okay. This is a branch. This is a branch. This is a branch. Yes, tama, no? May sumagot. All of the elements are actually my branches. No? So these are my branches. V1, V2, R1, R2, R3, R4, R5, R6, R7, and I. Okay, those are my branches. Okay, now, identify all essential branches. So dun sa branch kanina, dun sa mga branches kanina, ano yung mga essential branches? Essential branches are paths that connect essential nodes. Okay? So if I take a look at my essential branches, ano siya, no? Okay. This is one essential branch. Okay? It connects two essential nodes, no? It connects C and B without passing through any essential node. So, ang definition ng branch, it connects two essential nodes without passing through any essential node. So, this is one branch. This is another branch. Okay? This is another branch. Okay? This is a branch. This is an essential branch. We're talking about essential branches, no? This and this. So, those are my essential branches. I have 1, 2, 3, 4, 5, 6, 7 essential branches. Okay. So that's V1, R1, that's 1, R2, R3, V2, R4, R5, R6, R7, and I. Those are my essential branches. Okay, later on, you're going to find that the number of currents in a circuit is essentially, or I don't want to use the term again, no? The number of currents is the number of essential branches. Kung ilan man yung essential branches, yun din yung number of currents dito sa circuit na to. Okay, remember that the current, if two elements are in series, there's only one current that flows. No? That's why that happens. Okay. Give examples of at least 3 loops in the circuit. So what is a loop? In a loop, you start at a node, and then you end at the same node. No? So you trace a path starting at a node, ending at the same node, without passing through any element twice. So I'm just going to give, okay, somebody said C, F, G, E, D. No? C, F, G, E, D, C. Idagdag mo yung C. Sabi ni Jamie Lim, no? C, F, G, E, D, back to C. Okay? So that's an example of a loop. Okay? C, A, B, E, D, C, C, A, B, E, D, C, that's another example of a loop. Actually, madaming loops dito, no? For example, C, A, B, I can go this way, up there, and then end up all the way back to C. That's also an example of a loop. Okay. Anyway, this is one loop. I'm just asking for 3 loops. This is another loop. And this whole thing is also a loop. By the way, no? How many loops are there? Can somebody tell me how many loops there are? Anyone? Anyone willing to guess? 7, 9, 6, 11. Ang bilang ko 12. Ang bilang ko 12. Anyway, just count it on your own, ano? I might be wrong, but I counted 12 possible loops, 12 possible distinct loops in this particular circuit. Now, identify all meshes. Anong ibig sabihin ng mesh, no? A mesh is a loop that does not contain any other loop within it. So question, is FCABEGF a mesh? Is this a mesh? Ito? Is that a mesh? No. Why? Because within that mesh, you have this loop and you also have this loop. So ang definition ng mesh, dapat walang loop dun sa loob ng mesh. Having said that, how many meshes are there in this particular circuit? There are 4. There are 4 meshes. So these are your meshes. Okay? It's very easy to identify the meshes if your circuit is planar. So this is a planar circuit, no? Planar circuit. No? Ang ibig sabihin ng planar circuit can be drawn without overlapping wires. No? That's what you mean by a circuit. If you can draw the circuit without overlapping wires, then you call that a planar circuit. No? And it's very easy to identify the number of meshes in a planar circuit. No? The number of meshes is equal to, you call it the number of window panes. Window panes. You treat each of this like a window pane para itong ano, no? Para itong bintana. So these are the different panes. No? You treat each as a different pane and you count the number of window panes, and that's the number of meshes in a planar circuit. Okay. Circuit analysis using KCL and KVL. How many simultaneous equations must be solved? Given a circuit, how many simultaneous equations must be solved? No? The number of unknown currents in a circuit are equal to the number of essential branches B whose currents are not known. No? Naalala nyo, sabi ko kanina, the number of currents that will flow in a circuit will equal to the number of essential branches. Well, you get the essential branches whose currents are not known, and that would be your number of unknown currents. Unknown currents in a circuit. The number of essential branches whose currents are not known. So if we want to solve for all of the unknown currents, we would have to solve for B independent equations involving the B unknown current. So simultaneous equations to. So this is your math. This is your college, your high school algebra, no? Or your senior high algebra. You have to set up a system of B equations with B unknowns. If the circuit has n essential nodes, we can form n minus 1 independent KCL equations. if there's n essential nodes, we can form n minus 1 independent KCL equations. Naalala nyo yung one node circuit natin? You recall that when we were discussing KCL and KVL, right? This is an example of a one node circuit. A one node circuit. The reason why you call this a one node circuit is you can only form one independent KCL equation. Kasi pag nag-KCL ako rito, okay, let's say this is I1, no? This is I1, I2, I3. Let's say this is I4, no? I4. If I do a KCL here, I'm going to get minus I4 plus I1 plus I2 plus I3 is equal to 0. Okay, if this is I4, this will also be I4. No? That is always the case, no? And if I do a KCL here, what am I going to get? I'm going to get I4 minus I1 minus I2 minus I3 is equal to 0. Notice that these are the same. That's the same. So when you have n essential nodes, you can only form n minus 1 independent KCL equations. And that's true for, no? Let's say I have this circuit, no? Yung circuit na ginawa ko kanina. Okay, so let's say this is I and this is also I. Okay. So how many essential nodes do I have? 1, 2, 3, and 4. Say this is A, B, C, and D. Okay. You can try this on your own, no? But if you write KCL for A, B, and C and simplify, you will get the KCL for D. No? You will get the KCL for D. In other words, you have four essential nodes here, A, B, C, and D. But you can only write 3 KCL equations because the fourth equation can be derived from the other 3. Okay. So, going back, no? I can form n minus 1 KCL equations. I have B unknowns. I can form n minus 1 KCL equations. I need an additional B minus n minus 1 KVL equations to complete the number of equations needed. Ulit, ano? I have B unknowns. I have n minus 1 KCL equations. So where do I get the remaining equations I need? The remaining equations I need, which is B minus n minus 1, that would have to be from KVL. Now, what will I apply that KVL to? No? That KVL, itong KVL na to, will be from the meshes. The KVL will be from the meshes. So let's go back to this previous example. So the known quantities here, we assume to be the resistance values and the independent sources. So lahat nito alam ko. Yung R1, R2, R3, R4. Alam ko lahat yan. Lahat ng R. No? Alam ko yung value ng V1, alam ko yung value ng V2, tsaka alam ko yung value ng I. I have 7 essential branches. We already identified that earlier. So what does that mean? That means I have 7 currents. No? 7 currents flowing in the circuit. So ibig sabihin nito, there are 7 currents flowing. Okay? Saan yung mga currents na yan? No? Pwedeng isa to, isa to, isa to, this one, this one, this one. Ngayon, yung current dito, alam ko, no? This current here, I know. It's given. It's one of the given. So how many unknowns do I have? I only have 6 unknown currents. I only have 6 unknown currents. Okay, so 6 essential branches have unknown currents. So I need to solve 6 simultaneous equations to solve for 6 currents. So question, just to keep you guys awake. How many KCL equations can I form? How many KCL equations can I form? I got an answer from Rick Ancheta, 4. Tama ba yung 4? Somebody says 5. Okay. How many KCL equations can I form? No? How many essential nodes are there in this circuit? How many essential nodes? Okay. This is one essential node. This is another essential node. This is another essential node. And this is another essential node. No? So actually there are 4 essential nodes. So how many KCL equations can I form? That's right, no? Sabi ni John, I can form only 3 KCL equations. I need 6. I need 6, no? To solve for all my branch circuits that I don't know. I have 4 essential nodes, so I can form only 3 independent KCL equations. So may kulang pa akong 6. 3. May kulang pa akong 3. I have 6 unknowns. I can form 3 KCL equations. Kulang pa ako ng 3. Yung 3 equation na yun, I'm going to use KVL. Can be formed by applying KVL to the available meshes. By the way, there's a question. Yes, that's right. No, we don't have to use. Well, there are only 4 meshes. There are only 4 meshes. I'm going to explain later on. Why you only need 3, or why you can only form 3. Okay. Actually, you don't have to use the meshes. You can use any loop. No? I can use any loop. Pero ang maganda pag ginagamit nyo yung meshes is when you use the meshes, you are sure that your equations will end up being independent. No? I'll give you an example. No? I can form KVL for this loop. No? I can form KVL for... No. Dito muna, no? I can form KVL for this loop. That's one equation. No? KVL for C, A, B, E, D, C. No? That's one equation. I can say KVL for C, D, E, G, F, C. That's another equation. Okay? So, ito yung 1. Ito yung 1. KVL dito. Ito yung 2. Now, what if my third KVL, excuse me, no? What if my third KVL is FCA BEGF? What if this is my third KVL? If you do that, you're going to find out that the third KVL, the KVL for FCA, this can be derived by simplifying 1 and 2. No? In other words, this plus this, if you combine that, you're going to get this. And therefore, those are not three independent equations. So that's why when we form our KVL, the safest thing to do is to use the available meshes. Because when you use the meshes, you are sure you are forming a set of independent equations. That's a very important thing to remember. No? You have to make sure that your KVL equations are independent equations. Okay? So, ito na, no? Minark ko na yung unknowns ko. Right? My 6 unknown currents, I already marked them. That's I1, I2. I skipped I3, ano? I1, I2, I4, I5, I6, and I7. I skipped I3 para yung current at saka yung resistor value pareho yung subscript, no? I1 flows to R1, I2 flows to R2 and R3. Okay, I4 flows to R4 and so forth. Ano? So those are my 6 unknown currents. So we need 6 equations involving these 6 currents. I can only form 3 KCL equations. No? So what is the KCL equation for node B? For node B, it is negative I1 plus I5 plus I7 minus I. So again, the convention that we usually use is, and this is just convention, no? You can follow your own convention. You sum the currents that are moving away from the node. No? If it is going toward the node, then it becomes negative. So it's minus I1 plus I5 plus I7 minus I is equal to 0. Make sure that you include all of the branches that are connected to that particular node. No? So there are 4 branches connected to B. You have this branch, this branch, this branch, and this branch. Therefore, you have to have 4 terms. What is the KVL equation for node C? For node C, it's simply I1 plus I2 minus I4. And finally, what is your KVL equation for node E? For node E, it's I5 minus I5, sorry, minus I2, that's right, minus I6 is equal to 0. There are only 3 branches connected to node E. So in this case, ginawa nating reference yung node G. Inetsapuera natin yung node G sa KCL natin. When you eliminate one of the nodes because you're performing KCL, in effect, you're making that node like your reference. Remember that if I form KCL for node G, I can derive that from these 3 equations. That's why the KCL for node G will not be independent of the KCL from node B, C, and E. So tatlo yan, no? So these are the 3 KCL equations that I can form. Some things to note. First, the current directions may be assumed. If we do not know the current direction, we can assume it. Now, when we do the computations, if we get a negative computed value, that will indicate that the assumed direction is wrong. Okay, this one I already mentioned. No? The KCL equation for node G can be derived from 1, 2, and 3. by eliminating I1, I2, and I5. It is not independent of 1, 2, and 3. So, ilan ang KVL equations na kailangan natin? We have 6 unknowns. We already have 3 here. So we need now an additional 3 KVL equations. And that can be obtained by applying KVL to the meshes of the circuit. No? So for example, mesh 1. Let's say we're going mesh 1 in the clockwise direction. Mesh 1 in the clockwise direction. So ano yung magiging KVL equation natin for mesh 1? No? For mesh 1. So this is minus V1, no? Minus V1. Negative to positive is minus. Okay. Plus VR1. But what is VR1? What is VR1? VR1 is I1 times R1. So this is VR1. That is equal to I1 times R1. Okay? Plus, what is VR5? VR5 is I5 times R5. Okay? What is VR3? Okay, take note, no? The current flowing in this branch is flowing toward the right. Therefore, the polarity of R3 will be plus minus VR3. Therefore, this is going to end up minus I2 times R3. Okay, and then you have minus I2 times R2, and this is equal to 0. So this is for mesh 1. Okay. So that is your fourth equation. For mesh 2, you have something similar, minus V2 plus I2R2. Okay. This time, okay, remember, ang polarity natin ngayon across R2 would be potential drop in the direction of I2. So now magiging plus to, plus I2R2 plus I2R3 plus I6R6 plus I4R4. That's equal to 0. That's my fifth equation. Okay, question. I have 2 remaining meshes. Remember, I need one more KVL equation. I have 2 remaining meshes. This is one mesh. Let's call this mesh 3. And let's call this mesh 4. Saan ako mag-a-apply ng KVL? Sa mesh 3 o sa mesh 4? So just a question for all of you to think about. Mesh 3 or mesh 4? Somebody said mesh 4. Somebody said mesh 3 pero hindi sigurado. Sino mas madaming sagot? Mesh 3, mesh 4. Okay. Let's try applying KVL sa mesh 4. Kunwari, no? Let me try to apply KVL sa mesh 4. So this way. Mesh 4. Okay. What will my first term be? My first term will be, okay, I'm going clockwise, no? So my first term will be the voltage across R7. The voltage across R7 is I7 multiplied by R7. Plus or minus? Tanong ko sa inyo, is that going to be plus or minus? Minus. Correct, no? It should be minus. Why? Because it's a voltage rise. Okay. Tapos na ba yung KVL ko? Yes or no? Di pa, no? Why? Because I still have a voltage here. No? I still have a voltage this way, no? V's of I. I still have a voltage here. So this is going to be plus V's of I is equal to 0. notice I introduced a new unknown. Okay, I introduced a new unknown. And therefore, instead of having 6 unknowns now, I'm going to have 7 unknowns. But I'm only forming 6 equations. So, meaning to say, no, it is not advisable to use mesh 4. No? So, don't use KVL on mesh 4 because I don't know the value of V of I, no? The value of the voltage across the current source. So where will I apply KVL? I will apply KVL to mesh 3. So nakompleto ngayon yung 6 equations ko. Okay, so I mentioned this earlier, applying KVL on the meshes will ensure a set of independent KVL equations, and KVL is not applied to mesh 4 because we do not have an expression for the voltage across the current source I. So we don't want to introduce a new unknown. Okay. So anyway, 6 equations, 6 unknowns. So it now becomes an algebra problem. So hindi na EE problem yan. It's already an algebra problem. Let's take an actual example. For the circuit shown, solve for the values of I1, I2, I3, I4, I5, and IX. Solve for the value of I1, I2, I3, I4, I5, and IX. Okay. Ginawa ko lang mas interesting yung problem na to by putting a controlled source. So this is a current-controlled current source. No? It is a current source, and what controls it is a current. That's why it's called a current-controlled current source. Another term is a current-dependent current source. So how many unknowns do I have? I have 1, 2, 3, 4, 5, 6 unknowns. 6 unknowns. I need to form 6 equations involving these unknowns. So tanong ko sa inyo, how many KCL equations can I form? How many KCL equations can I form? Okay, I'm seeing the correct answer. No, how many essential nodes do I have? I have 4 essential nodes. My essential nodes are A, B, C, and D. I have 4 essential nodes. So I can form 3 KCL equations. From the 4 essential nodes can form 3 KCL equations. So this is the KCL equation for node 1. Please check it. See if you understand how to do KCL. Okay. So minus 8 plus I1 plus I2 plus, ano yung current dito na nagpa-flow? The current that flows here is 4IX. Plus 4IX is equal to 0. For node B, again, check. Minus I2, okay, current is entering, so negative, plus I3, because the current is moving away, plus IX, current is moving away, is equal to 0. And finally, for node C, okay, minus I3, because the current is entering, plus I5, okay, plus I4, minus 4IX is equal to 0. Ito common mistake to, no? You might forget one term. No? Always count the number of branches connected to that node. So in node C, you have 1, 2, 3, and 4. You have 4 branches. So that means you have to have 4 terms here. You have to have 4 terms here. So tatlong KCL equation yun. Okay, now I form my remaining 3 equations. So kailangan ko ng 3 pa, no? Because I have 6 unknowns. So the 3 remaining equations I can form by applying KVL to the meshes. How many meshes, by the way, how many meshes does this circuit have? How many meshes? It has 5. No? So this is one mesh. Like I said, no, parang yung mga pane ng bintana. This is another mesh, another mesh, another mesh, and finally this is another mesh. Will I apply KVL to this mesh? No. Bakit? Tama yung no. Because I don't know the voltage across my 8 ampere source. That's why I don't want to apply KVL there. Will I apply it to this mesh? No? Ganun din. Ganun din, no? Hindi ko alam yung voltage dito sa current source na to. Dito pwede. Dito pwede. Kasi alam ko naman yung voltage dito eh. No? So I can apply KVL here. So the choice of meshes that I will apply KVL to would be mesh 1, mesh 2, and mesh 3. No? By applying KVL to those meshes, I will not be introducing any new unknown. Any new unknown. So this is my mesh 1 equation. Again, you can check it. So this indicates the direction in which I am traversing the mesh. No? So I'm traversing the mesh in the clockwise direction. So meaning to say I'm going from negative to positive. That's why it's 10I1. And then here I'm going from plus to minus, so it's 20I2. And then here I'm going plus to minus, it's 30Ix. That's equal to 0. Okay. And then for mesh 5, so that's my fourth equation. For mesh 5, okay, again, this is negative to positive, so it's negative. So minus 30Ix, 40I3, 60I4 is equal to 0. And finally, for mesh 3, negative 60I4 plus 50I5, to plus 2 minus, so plus 10 is equal to 0. So 6 equations, 6 unknowns. Okay, so there's a question here, no? Is the rule of thumb to avoid the current sources in choice of meshes? In general, yes. No? In general, yes. Avoid the current sources when you do KVL on meshes, because you don't know the voltages across your current sources. Unless, malay nyo, no? Unless sometimes that voltage is given. So it really depends on what is given and what is not. But in general, you're right. In general, avoid current sources when you form meshes, or when you do KVL on meshes. So 6 equations, 6 unknowns. So hindi ko na ituturo sa inyo paano gawin yan. Kasi high school, senior high, dapat alam na nyo paano gawin yan. Ano? There are many methods available to you. Yung mga calculator ninyo, unfortunately, hanggang ilang simultaneous equations ang kaya ng calculator natin. I think my calculator here, which is a Casio, can only do up to 4 equations in 4 unknowns. So kung mabigyan kayo ng problem sa exam na more than 4 equations in 4 unknowns, sorry na lang, you're going to have to do that manually using pencil and paper. Otherwise, you can actually use your calculator. No? May simultaneous equation function to. Okay. In this particular case, I cheated. I used MATLAB, so I just got the answers using MATLAB. So these are the answers I got. If you try to solve it simultaneously, I hope you get the same answer, because I think I checked this anyway. No? So any questions? That's the general procedure. So So you're seeing now, this is a more structured way of solving circuit problems than just indiscriminately using KCL and KVL. No? Kasi up to this point, hanggang sa last week, nung inintroduce yung KVL at saka KCL, theoretically, kaya mo nang isolve lahat ng problem, except that you're going to have to hack out a solution by writing as many KCL and KVL equations as possible. So now, this is a more structured way of doing it. Any questions? Okay. Actually, this is not yet the ultimate method that we are recommending. So I only introduced this to you to segue into nodal analysis. There are two popular techniques used in electrical engineering for circuit analysis for cases when you have many unknowns in your circuit. No? Kasi kailan natin ginagamit ito? No? Ginagamit natin itong method na to pag madami tayong unknown. For example, we want to compute for all of the currents. We cannot do circuit simplification, so we have to use this technique. Now, there are two even simpler techniques for doing circuit analysis when you want to reduce the number of simultaneous equations that you need to solve. The first is what we call nodal analysis, and the other is what we call mesh analysis. So dalawa yan. No? May tinatawag na nodal analysis and may tinatawag na mesh analysis. And you can guess that in one, you are going to use Kcl equations, and in the other, you're going to use KVL equations. Dito sa nodal analysis, we are going to use Kcl equations on our essential nodes. And dito sa mesh analysis, you are going to use KVL equations in your meshes. Now, in EEE123, hindi sinama itong mesh analysis. No? Hindi sinasama itong mesh analysis. Hanggang nodal analysis lang tayo. You're going to study mesh analysis, I guess, in a future course. But what is nodal analysis? No? This is a systematic method of analyzing circuits which reduces the number of simultaneous equations needed to solve for all the required circuit quantities. Kasi kagaya dito, no? I don't want to solve 6 equations in 6 unknowns. Although ngayon, madali na talaga, no? Dahil sa mga calculator, dahil sa mga MATLAB or Octave, no? Tools that you have in your computer, it's quite easy now, no? Not like in our time, in my time, I'm not saying our time, no? In my time, where we really had to use our pencil and paper. No? But we want to further simplify it. We want to further reduce the number of simultaneous equations needed to solve for all required circuit quantities. In nodal analysis, typically the number of simultaneous equations needed would be equal to the number of essential nodes minus 1. So dun sa problem natin kanina, where we did 6 equations in 6 unknowns, if I use nodal analysis, I can solve that problem now 3 equations in 3 unknowns. The method is based on the fact that if you know all the node voltages in a circuit, you can solve for any branch voltage. And if that branch is a resistor, you can express the branch current in terms of the node voltages. So I'm going to go back to this let me go back to this. No? So you saw that here I needed 6 equations in 6 unknowns to solve for all of the currents. But here is what we will do in nodal analysis. No? We are going to make one particular node, our reference. So this is the reference node. Okay. And then to each essential node, we will assign a node voltage. So here I'm going to have V's of A, here I'm going to have V's of B, and here I'm going to have V's of C. And ang sinasabi ng nodal analysis technique is, if I know V's of A, V's of B, and V's of C, I can solve for all branch currents of branches containing resistors. If I know VA, VB, VC, I can solve for all branch currents of all branches containing resistors. For example, what is the value of I2? Example, no? What is I2? I2 is VA minus VB all over 20 ohms. Okay. Any current, what is the value of I4? Who can tell me what the value of I4 is? Shout it out or type it up. That's right. No? I4 is just VC over 60. Okay. Ito, this is a little bit tricky. What is the value of I5? What is the value of I5? Somebody says 10 over 50. I'm glad somebody says, so ang mga sagot is 10 over 50, no? Yung isang sagot is VC over 50. Okay, I'm glad that some of you are answering this, no? Okay, may sumagot. This is the correct answer, no? VC, sorry, no, not the correct answer. Baliktad, no? It's, okay, tama. VC, this is VC minus 10 over 50. Okay, this is the correct answer. VC minus 10 over 50. The value of this voltage here is 10 volts. No? That is the voltage at this point with respect to ground. No? So let me call this V of E, no? Is 10 volts. V of E is 10 volts because of this 10 volt source. So I5 is actually VC minus VE or minus 10 over 50. Now, I want to warn you, ano? Common mistake to, no? Somebody will say 10 over 50. When you use Ohm's law, no, in Ohm's law, okay, you have I is equal to V over R. This is the current through R, and this is the voltage across R. Yung pag sinabi mong 10 over 50, 10 is not the voltage across your 50 ohm. No? Andito yung 10 volts, hindi yan yung voltage across your 50 ohm. So please don't make this mistake. No? And I'm glad somebody answered that because that is a very common mistake that students make. Ano? They see a voltage source and then they see a resistor near it. Then right away they use Ohm's law. This is not the voltage across this resistor. Okay. So, so this is wrong. No? Now, it is also not VC over 50 because VC is not the voltage across your 50 ohm. The voltage across your 50 ohm is VC minus 10 over, that's the voltage across your 50 ohm. So anyway, my point is this, no? If I know VA, VB, and VC, in effect, I can solve for all of my unknowns. Solve na lahat ng unknowns ko, no? Any of the currents here that I want to solve for, I will be able to solve for by just knowing VA, VB, and VC. And therefore, what do I have to do? I just have to form 3 equations involving VA, VB, and VC. So that is what I'm going to do in nodal analysis. And this is general procedure. Okay. I'm going to leave it here for you to read, no? But actually, this is already the topic of our next lecture, no? This general procedure. Label all essential nodes in the circuit. If reference node has not been designated, select a reference node. Assign a node voltage variable to each of the remaining essential nodes. Identify the node voltages which can be determined by inspection and so forth. For the remaining essential nodes, write the appropriate KCL equation, solve the system of equations, and solve for the required quantities from the node voltages. Yeah. There's a question. Di po ba papansin ng direction ng current sa sign? Yes, exactly. No? You have to take into consideration the direction of the current. In other words, if I have a resistor here, let's say this is A and this is B. If my current is this way, I is VB minus VA over R. No? And this is R. No? It's always the higher potential is always the terminal where the current is entering the element. The lower potential is always the terminal where the current is leaving the element. No? So you have to take into consideration the sign. Yeah. So there's a question here. Can you use Gauss-Jordan elimination, whatever? Yes, you. Like I said, no. This is no longer a course in math. As long as you form the equations and are able to solve it, then you can use whatever method you want to solve it. You can use matrices. You can use Gauss-Jordan. Para sa akin, use your calculator. Andiyan na siya, no? Use your calculator. Hanggang 4 unknowns yata kaya ng calculator ninyo. Any other questions? Anything you want to go back to in last week's lecture? Kasi medyo minadali ko na yung last part ng last week's lecture, no? Gusto ba niyong balikan yung last example last week? Or are you okay with it? We can go back to that, ano? Since we have a little bit of time. Sige, but before that, ano, any questions with regard to the lecture for today? Okay, anyway, if a question comes up until I close the session, you can still ask it. Sige, balikan natin yung last example last week, no? Because we ran out of time for that. Let me just close this. Okay. Actually, this is not the first time you're seeing this example, no? Because this example is exactly the same example that was given in week one, ano? The end of week one. In the end of week one, the way this problem was solved was using Kirchhoff's voltage law and using Kirchhoff's current law. No? To determine V last week, to determine this voltage V, we used KVL in this particular loop. And to determine the current that is flowing through this resistor, we applied KCL to this particular node. No? Well, it doesn't matter, either to this node or to this node. Okay. But actually, this problem can be solved using voltage divider and current divider. First of all, just to describe what this circuit is, this is actually a transistor amplifier circuit. So this is really an electronics problem. You're going to study bipolar junction transistors. Okay. Later part of this course, you're going to study bipolar junction transistors, but not yet as an amplifier. No? So in 131, you're going to study a BJT amplifier. This is the model of your BJT amplifier when it is operating in what is called the linear region. That's not important for you to know now. Important is that this is the model. You can represent a transistor this way. This is your source, the source of your signal, and this is the load. This is what you connect to the output. This circuit actually only works for AC. It does not work for DC. That is something that wasn't very clear when it was presented in the end of week one. So here, these values are not DC values. These are actually what are called effective values. Tinatawag dito effective value. Don't worry about that term first. You're going to learn what that term means when you study AC circuits later on in this particular course. No? But for all intents and purposes right now, you just think of it as DC, even if it is not really DC. Because effective value is like an equivalent DC value. So if you have the circuit, the problem is find the effective value of the output voltage V sub O if G sub M is your transconductance here, actually, that's what you call it, is equal to 30 milliamperes per volt. Okay, so I want to know this current. No? I want to know this current. Let's call this I1. For me to know what I1 is, I have to know the value of V. Okay. Now, how do I determine the value of V? I can use voltage divider here. No? V is equal to V in, VI, times 2K all over 500 ohms plus 2K. That's using the voltage divider principle. No? So this voltage will divide itself between this resistor and this resistor, or the term I used earlier was distribute itself between the first resistor and the second resistor. Okay. Now VI is equal to 2 millivolts. So what will V come up to? I'll have to compute it. This will come up to 1.6 millivolts. Since VI is equal to 2 millivolts. Yeah. Okay, so what is the value of I now? I is equal to 30 milliamperes per volt, okay, times 1.6 millivolts. Okay. What I'm going to get is 48 microamperes. Because this is milliamperes, this is millivolts. So I multiply 30 by 1.6, that's 48. Milli times milli is micro. So I'm going to get 48 microamperes. Okay. This I1, this flows this way. No? It cannot flow this way. It cannot flow that way because there is no return path. No? For this current to flow this way, there has to be a path for it to return. No? So hindi mangyayari yon. No? So let me just mark it as no current. There is no current here in this particular branch. Okay. So ano mangyayari? Yung I1 will distribute itself this way. Let's call this I2 and let's call this I3. So pwede tayong gumamit ng current division dito. You can use current division. What I want to know is I3. Okay. So my formula is I3 is equal to I1 multiplied by 75K all over 75K plus 10K. So this is the special formula for current division when you only have two resistors in parallel. So what am I going to get? I'm going to get 42.35 microamperes. Okay, 42.35. So what is now VO? VO is just equal now to minus I3 times 10K. So this is 423 millivolts. No? This is 423.5 millivolts. Negative. So that's why you can see it's an amplifier, no? Ang pinapasok natin dito is 2 millivolts. Ang lumalabas dito, the magnitude of the voltage here is 423.5 millivolts. Nagiging negative nga lang yan. Ang ibig lang sabihin ng negative, remember that that's not a DC quantity, it's an AC quantity. Habang umaakyat yung isa, bumababa yung isa. No? So pag ganun siya, the two voltages are, you call them out of phase. No? While one is going up, the other is going down. So this is how you will see the two voltages vary with each other. But this is small, and then this is big. That's how that circuit works. Okay? So that's why it's an amplifier. Are there any questions? Yeah, I suppose there's a question. Can you apply methods for circuit analysis discussed in week 2? In general, yes. No? Ang hindi lang pinapagamit pa sa inyo is nodal analysis. No? But yeah, I guess you can. No? I guess you can. Because actually what was discussed in week 1 and week 2 are really quite similar. No? Parang building up on top of each other. Any other questions? So if there are none, then that's okay. Ano yung sagot sa B? Answer in B, you divide 423 by 2. Yun lang. That is your amplification factor. For that's by how much it will be amplified. Ano? The gain, in effect, ang tinatanong dito sa B is the gain. Ano? Your gain, magnitude of the gain is equal to 423.5 divided by 2. That's why I said magnitude, no? That's why I said magnitude. Actually, yung tamang sagot is ilalagay mo yung negative sign. Okay? Okay, so that's the end for today. So see you again next week, no? And watch out for problem set 2, which will be released maybe tomorrow or Saturday. Okay. Okay, that's it. Thank you.